Hey, Year Sevens, I hope you all had a good holiday and you're ready to get back to it. Let's start by taking up Assessment 2 because on Wednesday, I think it'll be Wednesday this week, we're going to do Assessment number 3. And that'll include the new work that we're going to do this week, but as well as any kind of topics that we've had trouble with in Assessment 1 and Assessment 2. So we're constantly going back to practice those over again, so don't forget about them because we're trying to prepare for the end of your exams and, of course, for next year. Okay, so let's get started. Here we've got a diagram sequence where I've got one white square in the middle and 4 gray squares going around this outside. The next diagram, I've got a bigger white square in the middle and I've got 2 gray squares on either side, so that's 8 squares around the sides. And then on the next one, I've got a big white square in the middle and I've got 3 gray squares on each of the sides. By looking at a diagram like that, you should be able to find a rule here, find the pattern. Here I've got 1 gray square on each side, here I've got 2 gray squares on each side, here I've got 3 gray squares on each of these sides. So let's fill in the blank to describe the term-to-term rule. Now the term-to-term rule means how much is it changing from one diagram to the next. So from here I had 4 gray tiles, there I've got 8 gray tiles, there I've got 12 gray tiles. And every time I'm just adding 1 more gray tile on each of the sides of the square. So altogether I'm adding 4 gray tiles for each of these diagrams. So 4 gray centimeter squares are added to each of the diagrams to make the next diagram. Part B, it just basically repeats and makes clear what we've just said. Diagram 1 has got 4 gray tiles, diagram 2 has got 8 gray tiles, diagram 3 has got 12 gray tiles. How many gray centimeter squares would it take to make the 4th pattern? So if I were just to continue drawing this along, you would know what that would look like. I would need, instead of 3 squares on each side, I'd have 4 squares on each side. Also, you should be able to see my number pattern here, 4, 8, 12. The next one, it's going to be 4 more, like I set up here, 16. Okay, next, fill in the blanks to write this position to term rule. Now, I know this was a difficult one for us before because we're not just looking at the diagrams, but we're looking at the numbers here and we're saying from 1 to 4, what's the rule? From 2 to 8, what's the rule? And I set up the original or the general format of the rule for you, that the number of gray tiles is equal to some number in front of the number of the diagram. So that's some number times the number of the diagram. This is sum times table. If I look at the diagrams, this being diagram number 1, so when n is equal to 1, what do I need to multiply n by to get 4 gray tiles? So what times 1 makes 4? For the second one, I'm thinking this is the second diagram, so n is 2 here. What multiplied by 2 gives me 8 gray tiles? Because here there's 8 gray tiles. And again, it's the same rule for all of the patterns. For the third pattern, this is the third pattern here, where n is equal to 3. What number multiplied by 3 will give me 12 gray tiles? And in each of those cases, it's the same number. It's the common difference. It's the number that we're jumping by. And that number is 4. So my rule is G is equal to 4 times the diagram number. 4 times 1 gives me 4. 4 times 2 gives me 8. 4 times 3 gives me 12. And 4 times 4 gives me 16. Okay, so that rule works for any diagram in this sequence. So when you're asked about how many gray squares it would take to make the 50th pattern, you don't need to draw the 50th pattern. But if you did, you would be drawing a big white square with 50 gray squares on this side, 50 gray squares on that side, 50 gray squares on that side, and 50 gray squares on that side. Now that was a mouthful. I could have more easily just said 4 times 50, like I've got here with this formula. G is equal to 4n, so I'm going to write that. G is equal to 4, and I'm replacing the n with the number of the pattern, which is 50 in this case. G equals 4 times 50. When I've got a number in front of a letter, that means multiply. So G equals 4 times 50 is 200. There would be 200 gray centimeter squares. So I'll go ahead and try and squeeze that in here. 200 gray centimeter squares. And let's go on to the next question. The next question again is a sequence pattern, a diagram pattern. I've got one gray square here. Here I've got one in the middle, and I've got 4 on each side, so that's 5 altogether. And here I've got the same pattern as the previous one. So I've got the one in the middle, 4 on each side, 1 on each side, sorry, 4 altogether. And then I've got another one on each side. So over here I've got 1 in the middle and 2 on each side. That's going to make 1 plus 8 is 9. Okay, so I can go ahead and complete the following statement. On the first diagram, there's 1 gray tile. On the second diagram, I've just counted there. There is 1 plus those 4 is 5 gray tiles. On the third diagram, I've got 1 in the middle, plus I've got 8 going around, so that's 9 gray tiles. And I don't have the next diagram, but I can imagine what it looks like. I'm just going to add 1 more square on each of those sides. So that's going to be adding another 4 squares. 9 plus 4, that's going to be 13. Right? Now, I just used the term-to-term rule to work that out. I knew that every pattern was growing by putting an extra square on each of those 4 sides. So every pattern, I added 4 tiles. So filling in the blank to complete the position to term rule. So that's the hard one here, where it's the number of gray tiles is some number multiplied by the term pattern, the sequence pattern, sorry, number. And there is an adjustment in this case. So just like the previous one, I'm always adding 4 more tiles. So I'm going to write the number in front of the n. The common difference is 4. But this is not the 4's times table. Look at my numbers here. Over here I've got 1 to start with. Then I've got 5, then 9, then 13. That's not the 4's timetables. Some people might have made a mistake here thinking that we started with 5, but we didn't start with this pattern here. We started with this pattern here. So this is not higher than the 4's timetable. It's actually quite a bit lower than the 4's timetable, starting with 1. So I could say it's the 4's timetable, but I need to take something away from that. I need to take away 3, right? Because if it was a 4's timetable, it would start with 4 times 1 is 4, and I need it to start with 1. So 4 take away 3 gives me that 1, right? So how many gray tiles would we need for the 47th diagram? So now that I've got my rule over here, I'll do like I did in the previous question. G equals 4 times, and I'm looking for the 47th diagram. So in brackets, I'll put 47 minus 3. And I need to work that out. 4 times 47, G equals 4 times 4 is 16, 4 times 7 is 28. So 160 plus 28 is 188 minus 3. G is going to be 188 minus 3. G equals 185. So here my number of gray tiles is 185. Right, next. We've got these sequences here, these number sequences, and we're trying to figure out which number sequence goes with which rule. The easiest thing for us to spot, or at least the easiest thing I've noticed you guys spotting, is the common difference, what we're jumping by. So let's see if we can just identify the common difference and then by elimination see which one of the rules it is. So here 2, 5, 8, 11, 14, I can see that these numbers are jumping up by 3s. So I'm going to go ahead and have a look at my rules here. Which of these rules go up in 3s? Not this one goes down in 1s. This one goes up in 3s. Let's see if there's any other. This one goes down in 1s. That one goes down in 3s. That one, there's no number in front of the n, so that must be positive 1n. That goes up by 1s, and this one goes up by 4s. So we had it right there at the beginning. It's this one here. Goes up by 3s, and I've got my adjustment on there at the end. This is not the 3's times table. I start with a number that's 1 smaller than the 3's timetable. So that's why I've got that minus 1 there. This next one, 2, 1, 0, -1, -2, it's going down by 1s. Okay, I had a couple over here that go down by 1s. Either this one here, down by 1s, plus 4, or this one down by 1, plus 3. Now if I look at my sequence here, the -1's times table would start with -1, and this one starts with 2. That's 3 higher. So that's an adjustment of plussing 3s. Let's put this in a different color here, and that's this one here. Next one, I see that this sequence 3, 2, 1, 0, -1 is going down by ones as well, but it starts with 3. Instead of it starting with -1, it starts with +3. That's 4 higher than -1. So let's join this up. That's got to be, oops, that one. That's got to be this one up here. It's 4 higher than -1. So color, there we go. Next one, 3, 7, 11, 15, 19. These ones are going up. They're going up by 4s. Okay, so looking over here, it's none of those. I've already used all of those. This one's going down by 3s. This one's going up by 1 because it's 1n. This one goes up by 4. So I'll go ahead and draw this one in. And I hope that that's right because I didn't even look at my adjustment yet. But it was the only one that went up by 4s. This goes up by 4s, but it's not the 4s timetable. It should start with a 4 if it were the 4s timetable. It starts with 3. That is 1 less, so this is the correct. Next, I only got 2 left, so hopefully I've done everything else right so far. -2, -5, -8, -11. It looks like they're getting bigger, but they're getting more negative. So they're actually going down by 3s. So it's got to be this one, right? -3n. Let's just check that the common difference is -3. Yes, let's check that the adjustment is +1. Not the -3 times table. The -3 times table will be -3, -6, -9. We're starting at -2, which is 1 higher. That's 1 less negative than -3. So yes, that's right. Go ahead and draw that in. Change my color. And we're on to the last one here. -3, -2, -1. They may look like they're getting smaller, but they're actually getting less negative. So they are getting bigger. They're going up by 1s. And these is not the 1s times table. It starts with -3. It's starting quite a bit lower than the 1s timetable. That's like 1 minus 4. That is this one, n minus 4. Going up by 1, that's why it's 1n. And I'm starting with a number that is 4 less than the 1s timetable. Okay, let's go on to the next question now. We've only got 2 questions left, and these came up on assessment number 1, and I knew they were difficult then. They are still difficult now. We're going to keep practicing them, and don't be surprised if you see this on assessment 3 as well. Work out 3/16 of a day in hours and minutes. Okay, so 3/16 of a day. I'm going to do some working over here. 3 divided by 16 of a day. Now, a day is 24 hours. And I'm even going to write hours to make it clear that when I work out my answer, I'm working at a number of hours. So 3/16 of 24 hours, I'm going to do 3 times 24, and that answer is going to get divided by 16, right? Okay, so starting to think about what 3 times 24 is. 3 times 24, that's going to be 72 divided by 16. And that is definitely a top-heavy fraction. The top number, the 72, is bigger than the bottom number 16. So I'm trying to think, how many 16s go into 72? I know that 5 times 16 would be 80, so that's too big. So maybe I'll try 4 times 16. 4 times 16, that would be 64. So 64 is not exactly 72. That is 8 less than 72. So this is going to be 4 wholes and 8 over 16, right? Let me take you back through that again. I'll put it over here maybe. My thinking is that 72 is equal to 64 plus 8, right? I couldn't do 72 divided by 16. It doesn't divide nice and perfectly. But I can do 64 divided by 16, and that's exactly 4. I can't do 8 divided by 16 because 8 is smaller than 16. So I leave that as a mixed number. That is That is 4 and 8/16. Now I could actually simplify this now because 8/16 simplifies nicely. I can divide both the top and the bottom by 8, which leaves me with 1/2. And that's a much easier fraction for me to work with. So over here, I've got my answer in hours, and that is 4 full hours. 4 hours. And the 8/16, I'm going to need to convert that into some number of minutes. But as I've just said, 8/16 is half of, there's half, so that's going to be half of an hour. Half an hour is half of 60 minutes. So that's 4 hours and 1/2 of 60 minutes. Clumsy typing today. Okay, so that's 4 hours and half of 60 minutes. I'll put that in brackets so it's really clear. We still have something to calculate here. And half of 60, I'm hoping we can do mentally, but if you can't, we would have to do 60 times the 1 and then put that over 2. So that's 4 hours. And I'm doing this working for you just so that you can see it. This is 60 times the 1 is 60 divided by 2 minutes, which is going to be 4 hours and 30 minutes. Final answer, 4 hours, 30 minutes. 4 and 30. On to the next question. Tony slept through 3/8 of a 3-hour train ride. Ooh, this one's going to be a tricky one. We need to work out 3/8 of 3 hours in hours, minutes, and seconds. Okay, let's do this in a different color here so we can see what we're doing. 3/8 of 3 hours. So 3/8 of 3. And I'm going to be really clear that this is in hours. So when I work out my answer to this and it works out to be a mixed number, I know I've got the whole number of hours and I need to work out the number of minutes. Okay, so 3/8 of 3 hours, I'm going to do 3 times 3. And that needs to be divided by 8. Right? I just multiply by the top and then I divide by the bottom. So that's going to be 9/8 hours. Okay, so I need to think that's a top-heavy fraction. I need to turn that into a mixed number. How many 8s go into 9? There's 1 whole 8 in 9. And that leaves me with 1 left over, right? Because 1 times 8 is 8, and I need 9/8. So 1 left over 8. Okay. That means that it's 1 full hour, because I've been talking about hours this whole time. That's 1 hour. And I need to work out what 1/8 of an hour is in minutes. 1 hour is 60 minutes, so 1/8 of an hour is 1/8 of 60 minutes. And I'll keep working that way. I've got part of my answer now. I've got 1/3 of my answer now is 1 hour. And I'm working out 1/8 of 60 now to find my minutes. It's 1 hour. And 1/8 times 60, again, I multiply the top and then I just put that over the bottom. So that's going to be 60 times 1 is 60 divided by 8. Okay, that's top heavy again, so I'm going to turn that into a mixed number. I need to think how many 8s go into 60. That's 1 hour. And now I know 8 times 8 is 64. That's too much, so I'm going to try 8 times 7. 8 times 7, that is 56, right? It's not quite 60, it's 56. Let me do my working to the side again here so that we can understand how we're doing this. So, do some working to the side here. Okay. 60 is equal to 56 plus 4, right? The reason I chose 56 plus 4 is because I couldn't do 60 divided by 8, but I can do 56 divided by 8. And I still have 4 left over that needs to be divided by 8, right? So working this through, that means that 60 over 8 must be the same thing as the mixed number. 56 divided by 8, that's 7. And 4 divided by 8, I can write that as a simplified fraction that divides both top and bottom by 4. That's 1/2 again. So 7.5. Okay, so coming back over here again now with my working, I now know that 60 divided by 8 is 7.5. So this is now 1 full hour, still 1 full hour. The hours haven't changed, and 7.5 minutes. Now I'm hoping that if you get half a minute, you know how many seconds that is, but I'm going to show the working anyways because a lot of people got the hour right, and this is where they got their mistakes. So that's 1 hour and 7 minutes, and I'll work out the half a minute into seconds. 1 hour, 7 minutes, and 1/2 of half of a minute is half of 60 seconds. And half of 60, we've done it before. We can just go ahead and half 60, or we can say that 60 times 1, which is 60 over 2, so 60 divided by 2. So that is 1 hour, 7 minutes, and 60 over 2 seconds, which is 30 seconds. So 1 hour, 7 minutes, and 30 seconds. Bold, that's my final answer. Okay, now I know this kind of working is really tricky for you. I'll bet some of you have been asking for help at home and your parents have struggled a little bit with it to help as well. It's not something that we practice very often, but it is very useful to work in fractions and mixed numbers rather than decimals. So please keep practicing that. You are definitely going to see that again, so make sure that you're clear on it. Okay, you can practice making up any numbers you like, and just seeing, can I do a fraction of that amount? Can I turn it into hours, minutes, and seconds? You might have some answers where you end up with some fraction of a second at the end. Don't worry about those ones. I'll never give you a fraction of a second at the end. I'll always have some whole number of seconds. Okay. So just filling in my answers there. That's really clear. And we are done. So I'll just give you one last scan through that in case there's anything that you weren't quite clear about. Make sure that you do understand it all. And if you have any problems, let me know, send me a private message, and we'll see if we can clear that up for you. Okay? All right. Have a great day, guys.